J. Thomson, also known by his full name Sir Joseph John Thomson, was born on December 18, 1856 in Manchester, England, and grew up to be an English scientist who revolutionized the field of particle physics with his discovery of the electron. To understand how he was able to accomplish such a great feat, it's important to look at his life history. Although Thomson became a very established physicist, he wasn't born into a family of scientists at all. In fact, his mother was part of a family that worked in textiles, and his father was the owner of a rare books bookshop. His dad wanted him to become a train engineer, but his family could not afford to pay for his schooling. So instead, Thomson pursued his interest in science at the University of Manchester, where he studied general science and mathematics. Because of his great academic skills in undergraduate studies, he received a scholarship to study physics at Cambridge University. Once again, because of his undergraduate academic excellence at Cambridge, he was appointed in 1884 as a head professor of experimental physics. He became the director of Cavendish Laboratory, and he worked there for 42 years, making it one of the most renowned labs of experimental physics of the world at the time. He also became a professor at the Royal Institute in London in 1905, and the president of the Royal Society as well. Other than his education and career, it was J. Thomson's cathode ray tube experiments which completely changed the face of particle physics. In his first experiment, Thomson explored the possibility of separating the negative electric charge of cathode rays by magnetism. He built a cathode ray tube that ends in a pair of cylinders with slots connected to an electrometer, and expected that the cathode rays would be deflected by a magnetic field in such a way that they can't enter through these slots. From this experiment, he concluded that the negative charge cannot be separated from the rays. Like any great scientist, Thomson didn't stop there and went on to develop a second experiment to prove that the rays themselves carried a negative charge. To prove this, he attempted to deflect them with an electric field using two electric plates placed halfway down the tube. He hoped that the electric field produced by these plates would deflect the rays, and as he expected, the rays were deflected by the electric charge, and this proved that the rays themselves were made up of negatively charged particles. Other scientists had tried to observe this effect, but they were unsuccessful, and it was only J. Thomson who was able to get it right. His second experiment was very crucial leading up to his greatest discovery, the discovery of the electron. In fact, J. Thomson wrote in his paper, "As the cathode rays carry a charge of negative electricity, are deflected by an electrostatic force as if they were negatively electrified, I can see no escape from the conclusion that they are charges of negative electricity carried by particles of matter. But what are these particles?" To answer this last question, Thomson conducted his final experiment, to determine the mass-to-charge ratio of cathode rays by measuring their deflection within a magnetic field. Thomson eventually came to the conclusion that cathode rays were composed of atoms which themselves were made up of smaller particles which he called corpuscles, or, as we now call them, electrons. In other words, it was J. Thomson who realized that atoms themselves were not the smallest unit of matter, but instead they were composed of smaller particles, including the electron. Many scientists used Thomson's work as a base for their own, and eventually when the discovery of the electron was announced in 1906, Thomson was the one who was awarded the Nobel Prize. J. Thomson also lived to see several of his close students receive their own Nobel Prizes, including Rutherford and Francis Aston in chemistry. In fact, 6 of Thomson's students and lab assistants went on to receive their own Nobel Prizes later on in their life. As you can see, combined with his own research, the group of scientists Thomson fostered is what gives us, modern students of science, a new and detailed understanding of the smallest building blocks in the universe, atoms. Not only did J. Thomson greatly contribute to the history of physics, but he also made great contributions to modern physics as well, most notably through his invention of a mass spectrograph in 1910. Thomson's mass spectrograph was the device that led to the discovery in 1913 of the first isotopes. The diagram labeled A shows Thomson's design of a mass spectrometer, and the other two pictures, B and C, are modern-day diagrams of mass spectrometers today. Thomson's invention was the first example of the technique of mass spectrometry, a technique that measures the mass-to-charge ratio of ions. Mass spectrometry is not only used in physics, but it's also a popular technique used to identify chemical compounds in the field of chemistry. Other applications of mass spectrometry include drug testing and discovery, food contamination detection, and carbon dating. Thomson's cathode ray tube experiments also laid the groundwork for the use of cathode ray tubes to accelerate and deflect electron beams onto a screen to create images, which eventually led to the invention of the first television sets. In conclusion, J.J. Thomson's experiments led to the discovery that all atoms contain tiny, negatively charged subatomic particles, or electrons as we now call them, and this completely revolutionized the field of particle physics and physics in general. As you can see, the impacts of J.J. Thomson's discoveries are widespread and affects us all indirectly in all aspects of our daily lives, and I think that is the true hallmark of a great scientist. Thank you.